Hey everybody, how are you doing today? My morning's gone pretty well so far. Unity is taking an age to start up, so that's why running a little late today, but I think we'll be okay. Yeah, so yesterday we started working on the terrain mesh. Mostly we wanted to update the normals because before, when it was interacting with the toon shader, I'd gone with like a low poly pointy look, and the normals, and the way you achieve that is the normals just point straight out from every triangle. And I mean, that looks fine, but it doesn't really mesh well with the toon lighting shader that we've been working on. So I want to try and smooth the normals out for the terrain. And in order to do that, we have to sample the height map at certain points and then find the slopes. And in order to do that, well, we had to get the code ready to deal with all that extra information. So I've kind of been refactoring a little bit and at the same time making it a little more efficient. All right, so yesterday we stopped by figuring out the number of points that would be in this hexagon, because we're going to try to pre-calculate all these points so that they can be shared between triangles, because they'll all have the same information. And yeah, so we did some fun counting, tried to figure out the best way to deal with this. Yeah, so this is the beginning point, and for now we're just having the normals always point up because I just want to test to make sure that the code works. Right, and to clean this up, I think for now we'll just not have any margin code. I mean, obviously we'll need to add this back in later, but just so that the game won't continually complain to me about errors, I'll go ahead and hide that function. And what's the problem down here? So they add triangle. Oh yeah, so I haven't actually updated this yet. I don't need to create these triangles because that's what we're passing in. I can just close this. One other thing here is I need to add the vertex index for this. So what I'll do, a new function here, private int get new vertex. And so we have this num vertices variable, so we'll increment that and then just return num vertices -1 because that's the last vertex. All right. So now I just need to make these points for everything here. And okay, so R is for each ring. And then number of points in the ring. Okay, then this is for each point. So we're not doing it by wedge, which makes it a little easier, I guess. Although, I might need to change this to be per wedge. Because I'm trying to think. Hey, RD Atten, thanks for stopping by. Hope you're having a good morning too. I guess you're on lunch break, so thank you for coming. Let me see. Yeah, I think, see, I'm trying to think of how we could actually figure out these positions if I don't do it on a wedge basis. So this num points and ring might not be that useful. Now the number of points in a wedge is kind of this information here. Alice is counting triangles, but from that, I mean, it's kind of easy to see. So this is ring 1, and so it has 2, and just the number of points increases by 1 for every ring. So it's just the ring number plus 1, isn't it? Yeah, because this is 1, 2, 3. So that's kind of easy. I think I'll make another function for this though. Private void create hex fan ring points. And we'll need to pass the point array. Okay, so int num points in fan. Yeah, I was calling them a wedge, but I think I call it a fan in other places, so I'll just try to stick to the same terminology. Is again the... Oh, I don't actually pass the ring. And so now we also need to find the starting index, which would be, well, the number in all previous rings. And I found out the number in every ring is just... Oh, except I deleted it. Oh, the number in wedge is... Yeah, just a sum from 1 to the ring number. Yeah, because our ring number plus 1 actually, because this is ring 0, 1, 2, 3. So we have to sum 1, 2, 3, 4. So we counted the total number and the entire hexagon by taking the number in wedge and then multiplying it by 6 and adding 1. So basically we could find the index of this first by taking the total number of points in a hexagon of 1 less rings. So maybe I should have another function here. And that's just this. I guess I'll put this comment up here. So now the number in wedge is... I can simplify this a little bit. Oh wait, so I actually need... I need to multiply by 6 and add 1 for the center point. Okay, so now here I can just use the new function. And that's to find the total number of points. So for here we'll need to find the starting index is the number of points in a ring -1. I guess we would... No, we don't add 1 to that because this gives us a number, so the start index is that same number. Okay, so now for int p equals 0 less than a number of points. So again, we loop through that, and also I need to calculate this. So I guess we just need this, the near value, because the far value is on the other side. Yeah, so if we're on ring 1, for instance, which would be this one, near value would be here. Or wait, actually, well, it depends on how I calculate the index, but I want this value. So, I think in this index, in this function, the ring actually is referring to this. So this is ring 0. Okay, oh yeah, that's correct. So if I'm on ring 1 at this point, then I want the near value of this triangle ring. I should try to specify triangle or point ring, but... Okay, so we can calculate that just using this function. And I think that should do it. And then we just need to get the corner A, which corresponds to, you look at the hexagon and then move clockwise. A is always the most, I guess, counterclockwise point on the fan, and then B is the more clockwise point. Okay, so I don't have the cell yet. And that's about it. Now here we're actually, it's a little bit more complicated because it's going based on triangles. So I think we could just use, yeah, this is 2 points on the outer edge. And this is 2 points on the near edge. So I think we'd actually want this one, because this corner is probably this one. Yeah, because it's the first point. So yeah, this one goes 1 point farther clockwise, so we can always figure it out, but... So I guess I'll just call this point lerp equals... Change that to P, and... Oh yeah, I'm missing parentheses. Oh, it's lerping on the position. Okay, so that's fine. Okay, so the bump position will actually give us the height and also perturb based on the noise or distortion. So I think I can still use this. I don't know if that'd be best though. Although I'm gonna have to use this. Maybe I should make another function that's like get point, because, or that will compute a triangle point for us, because I'm going to need to create this a million, lots of times. Let me see. So private, let's actually, I don't know, it's not a great place to place it. Maybe back down where it was. We can see here, it's a little complicated because I have to average a few different values there, but that's not that big of a deal. But then this bump position needs to blend multiple prototypes together. And they all depend on previous versions. So yeah, we're gonna need to get the bump height. Actually returns a vector 3. Yeah, because it adds a flat position. But we're gonna need just the plain float because... Oh wait, what's going on here? Oh no, it just does just return a vector 3, but it only sets the height. I guess that's fine. But we're going to need to know the heights in order to calculate the slope at the specific point so we can figure out the normal vector. So really I just need to probably change these bump positions to actually just return a triangle point. So maybe I'll rename this. What's it complaining about? Namespace cannot directly contain members. Okay, I must have not closed parentheses somewhere. Let me just try and clean this up so I won't have so many errors. Oh yeah, right here. Actually, I know corner B. Yeah, I was gonna say corner B is just we add one to corner A and take modulo 6 so it loops back around if we get to the max value. We've got a few more errors down here, but I'm going to update them. Okay, so... Okay. Point is new, try point. And one thing I know is we're going to have a new vertex, so I can say get new vertex. Well, right now I am getting a bit ahead of myself because I'm just not going to calculate the normal yet until we know this rest of the code's working. So I'll just set that to up. What else do we need to know? The blend. Well, for this one with just one prototype, the blend is just red. Because it only has one terrain, so it doesn't have to blend at all. Okay, and so point dot position is just flat position plus bump height. Okay, we'll just go with that for now. And we'll have to update this later when we have it... Oh, what's it complaining about now? Have it actually take normals into consideration. But I'm happy to just update this function to return a triangle point for now. Okay, and here we do the same thing, except the blend is this lerp value. Let me look up where that's used. Okay, that's the terrain. Well, here it's all just red, red. Okay, so the lerp value seems to be the second. So I'd want to take 1 minus lerp and then lerp. Okay. That makes sense because it's going from proto A to proto B. And this is only between 2, so we don't have to set the third value. And then this is all just calculating the position. So point dot position equals. All right. And now the last one is combining 3 different terrain types. So we have to lerp between all 3 of them. And here it does get a little complicated because we actually have to use barycentric coordinates for the triangle. This is where I have this triangle average. So I need to figure out, I think it's L1, L2, and then 1 minus L1 minus L2. But let me make sure. Okay, I'm trying to find the, where I calculate these colors. I think I kind of cheat. The triangle center is just 1/3, 1/3. Okay, so I think this should be fine, but we can, when we actually have this to look at, we can try and figure it out. Oh, well, this is lerp between A and B, and then, wait, what does that even correspond to? Oh, if it's just between 2 and the third is null. That's, yeah, if you have a border case. Okay, that is kind of... Yeah, so I can't actually do this here either. Because if proto B is null, then the blend is also just simple. Okay, so I'm glad I caught that. So I actually have 3 possibilities. If B and C are null. What's this? Oh, I guess I could just do that. Bump position. Oh, I actually changed the name of it. All right, and then here, this update's fine. Yeah, I think this is kind of hacky because we can't always guarantee that it would be exactly halfway between, but for now we don't subdivide the margin triangle, so I think that's why that works for now. Okay, and at this point... Yeah, so we actually only make a new point here. And so triangle average, yeah, I think it multiplies bump A by L1, bump B by L2, and bump C by 1 minus L1, L2. So we'd actually do the same thing for the blending. Oops. Also hacky. Let me write a note for myself. Does not take into account extra rings in the margin triangle. which we don't do right now, so it works. But it does assume something about the code, and we'll have to update that if we ever do add rings in the triangle, which I can see doing, but... Okay, I don't know. Does this triangle average function actually help? I guess so. Okay, so now we updated all that. What's this error? Oh. This be a... Oops. Don't know why it gave me that suggestion. Okay, so now we actually have no errors, but if I ran the game, it wouldn't actually generate any terrain at this point. Okay, so now we're back to here, and I lerp the positions, so I can just set points start index plus p equals make new point position lerp, and then the prototype, which is just cell dot surface prototype. Okay, and then I just need to call this create hex fan ring points. All right, and I want to comment out. Well, I guess I don't need to do that because when you go to create margin, it doesn't actually do anything. I might want to take all this code into another function because this has to do with the actual hexagon face. Does this any of this? Okay, it does use this cell. Right, hex. Okay, well, that's fine. And I'll move this function down. Oh, I should have done this too. Alright, we're getting there. So now in this create hex fan, I can uncomment this. Because now we're not going to go by vertex rings, we're going to go by triangle rings, which is the space in between. So there's one less vertex ring, or one less triangle ring than vertex rings. And the number of vertex rings is... yeah, this +2, and then the number of triangle rings is just this +1, which is the same as checking if r is greater than, or r is less than or equal. Okay, so now let's update this function. It has a lot in common with the create points, but maybe it won't. I don't need this cell anymore because I don't have to access the prototypes, I don't think. Actually, I don't have to do any of this lerping. All I need to do is find the start index, which is... maybe I should call it the near index, which would be... Okay, so at ring 0, or triangle ring 0, which is this one, the near index is actually here. Which would be... yeah, just the ring, and then we need to subtract 1 because we don't want to find the next Or is that correct? So yeah, if we were at ring 1, then the near index would need to be 1, so it'd be the number... okay, actually... yeah, because actually I need to find this value, so it needs to count the number 2 rings down, so it is -1. Because we have to find the start. Oh yeah, these numbers are wrong. I should fix them before they confuse me. This should be 7, 8, 9, and then 10, 11, 12, 13, 14, 15, 16, 17, 18. Oh, and yeah, 18, and then 19. But anyway, okay, so at ring 0, we actually want to get the number 0. But if we send -1, that would give us something nonsensical. Okay, so if num rings is less than or equal to 0, we'll just return 0. So this is actually ring -1, and so the far index is number of points in hex of ring. I think we add 1 to this because we need to find the first point in the next set of rings. So if we're at ring 0, we want 1, so it's a number in a hexagon with 0 rings, which is 1. Or wait. Hexagon with 1 ring is right here. Am I calculating this correctly? Okay, a hexagon of 0 rings would give us something nonsensical. But I forget, is this 0 indexed or not? Just to go into counting total blocks. Number of points in a ring where R is 0 indexed. Okay, I should write a comment here. So hex of 0 rings is 1 point. I need to make sure that I calculate this correctly. Okay, so if it's less than 0, we return 1. Else if rings equal 0, we return 1. Otherwise, we count the total. Actually, so this would be a -1 times 0. We don't have to have a special for 0, actually. Okay, so where do I use that? So number of rings, so this would be, so this is, if hex rings is 2, then we have 4 point rings. Yeah, so this would actually be, rename number point rings. And I'll do that as well. Because I need to, in my mind, I need to just have a distinction between the point rings and triangle rings because I'm getting them confused. So sequence here for point ring 0 is 1 and then 7, which gives us that, and then 19. Okay, so anyway, this is fine. And then this one. So at ring 0. This should actually start at 1 because ring 0 is this one. I gotta do that. Oh, wait. No, we don't. Okay, so at ring 1, we subtract 1 because we want to get the start index. So number of points in a hex with 0 point rings, start index is 1. Is that? Yeah, so at 0, this is 0, and then of course 0 times 6 is 0, but we add 1. Okay, so I think I have the math correct. So for a triangle, the near index, for a triangle ring at 0, we want to get the number, we want to get this position, which would be the triangle ring minus 1. So yeah, so for triangle ring number 1, we want to get this point. Let's change it. Which would be number of points in a hex with point rings. Triangle ring number minus 1 because we want to get 1, so it's 0. Okay, I think I have this correctly. And so the far is just the same except it's the actual triangle ring number. Let's change this instead of just ring to tri-ring. And I'll change this to point ring as well. Oh, I need to actually pass the point array. Okay, so yeah, that's tri-ring minus 1. Okay, so here we create triangles with 2 points on the outer edge. And the number of that is a triangle ring plus 1 because on the 0 ring we just have 1, which is right here. So that's still correct. But I don't have to do lerping anymore. All I have to do is... Okay, I do need a cell for the texture index now that I think about it. It's vector 3, terrain. Oh, what's it complaining to me about? Oh, yeah. And then the other two are just 0. Okay, so I'll comment this out in case I need it, but it's just going to be add triangle points near index plus T, and then we also need to add in the corner. So in that we need to get the number of points in a wedge, or that's what this is, that's the T, okay. Okay, so let's do it. Let's add some more variables here. So int num in near, or let's do this, num points in near ring is try ring plus 1, and num points in far ring is just a try. Oh, that's not correct. That's the number of triangles. So the number of points in the near ring is actually equal to the triangle ring. +1, and the number of points in far ring is triangle ring +2. Because, yeah, ring 0, we have 1 and 2, and then ring 1, we have 2 and 3, and you just add 1 every time. Okay, so the number of triangles with 2 points on the outer edge is just the number of points in the far ring -1. Okay, so it's near index. Okay, and then I have to multiply by the fan that we're in, which is this corner A. Maybe I should add that here, actually. So plus corner A. Hey boy, Kojak, thanks for stopping by. What do you do if you can't concentrate on reading? For me, if I had to read something, I would just turn on some music and, I don't know, put my phone somewhere where I couldn't get it easily. But yeah, I kind of have to be in the mood. Okay, so I guess I actually need these variables first because so the near index, I think that's right, and then plus corner A times the music distracting for you if you're reading technical stuff. Not me. Like, yeah, I could see that it could be. It's a great tactic to put your phone as far as you can so you can't reach it. Yeah, definitely. The phone is very distracting. I also have an extension on Chrome that like only lets me visit very specific pages so that I don't get distracted by social media and things. I think it's called, I guess I can look it up. Strict workflow. So you might look into that if you also, if the browser is contributing. So let me see. Okay, so we have this and it's already built in to the fan that we're working on. So I can just add T. And then the next point, we've got to make sure that we're working in a clockwise fashion. So here we start there, and then I guess we'll go clockwise through the outer index or outer points. Far index, and we just add one more. +1, and I think here I need to So when I add this, I need to cycle back around to 0 when I get too far, but I can't do it to the whole thing. Okay. Oh, you don't have problems with that? Okay, well, that's good. So I think I need to separate this number out from here because this number needs to cycle back to 0 when we add one to it, but I can't cycle the whole index because then we'll go down a ring. Let's change this to fan. And then int num points in near ring is I guess num points in near fan times 6. And same thing here. And then I guess I'll just add this. I'm having to create a bunch of variables here, and I want to be very specific with their names so that I don't confuse myself later. So this will be near point ring start index, and this will be far point ring start index, and it won't have this part. Okay, and then near fan start index is, I guess I'll call it an offset because we just add it to it, is the corner A times number of points in the near fan. And then we do the same thing for the far fan. I might not need all these actually, but I'm just going to make them in case. Points and far. I'm just going to highlight to make sure that everything is symmetrical. Okay, so right here we have to add also this near fan start offset. Why? Because you're tired. Gotta completely stop thinking for a bit. No problem, boy Kojak. I hope it works out for you. And yeah, it definitely is hard to keep concentration when you're tired. I know how that is. So, far fan start offset. Okay, and then in this one we need to cycle. So it would be still we add those together. And then if it's greater than the number of points in the far ring, then we need to cycle back to 0. So that's what that does. Okay, and then last but not least, we just add in the terrain. So I think I might, before we tackle the other triangles, let's just test it now. Okay, gotta pass through this variable. I wonder what's wrong with that. Okay, yeah, some variables aren't used yet, but that's okay. Oh, we got an error. I was wondering why it paused. The supplied array needs to be the same size as the mesh vertices array. Terrain indexes. Interesting. Okay, well, let's see what's going on with that. Debug, log, string format, verts. And we'll just print out the counts of each. So num vertices and terrain indexes count. Unfortunately, I have to use a list because the set UVs doesn't take an array. So that's why it might not match up. Oh, what happened there? Okay, yeah, still an error. Verts. Okay, so it's just slightly off. Why do they have... Surprised there's so many vertices, to be honest. I guess... kind of makes sense. Oh, you know what? I think this num vertices doesn't get cleared every time we generate a mesh. That's kind of silly of me, so... Yeah, that's another thing that would have been fixed if we could use Unity's new entity component system, which I can't wait for that. This mesh renderer, our generator, is actually perfect for it because we could basically generate every mesh in its own, or every hexagon in its own thread, and that's perfect for the new system. Okay, so that does fix one error about why they kept getting more and more apart, but they're still not the same size. I don't really know how that could happen, because I have this function specifically to keep that from ever being an issue. I guess maybe we could have created a vertex but never used it in a triangle, so then the terrain would not be set for it. We actually want to find out why that could be. Well, that could that happen now? Because I'm not using all the triangles? Yeah, because I'm creating points for the entire hexagon. And if we're only creating these triangles... But I think all the points should still be used. Because these all on the outer edge. That means they probably got some math wrong somewhere. You know what? Let's simplify the mesh generation a bit. Oops, this is the wrong folder. So I want to go into the framework mod and change the number of hex subdivisions to 0. Alright, index is out of range, okay. So right now we're basically creating a hexagon, which is this. I wish it would tell me specifically which one's out of range. Okay, so there's only one. So right here, the triangle ring is 0, so that would mean the number of points in the near fan is 1 and far fan is 2, which we know. And then number of points in the near ring is 1 times 6, so that's wrong actually. This should be Yeah, this should be okay, I think this is the issue because I'm counting some points multiple times, so I need to subtract one. Yeah, because I'm counting the border points twice, so so I subtract one and then multiply by 6 and then add one to take into account. Is that correct? Let's see. For here, I need to subtract 1, multiply by 6. That's 0 times 6, and then I add 1 back, so I get 1. And then here, I would have 6. But the number, okay, so it gives me 2 as a number in a fan. So I subtract 1, multiply that by 6, and it actually gives me the correct number right away. What about here? So I have 3, subtract 1 for 2. And so that gives me 2, 2, 2, 2, 2, 2. Yeah, so there's no overlap. That's 2 times 6 is 12. Is that right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah. So it's only, again, this first one that's a little bit of an anomaly. So what I have to do is if try ring, let's do it this way, equals 0, then we just return 1, otherwise we calculate this. Otherwise it's fine. Okay, so let's keep going through this. So the number of points in hex of ring, so we already figured out the near start index. When try ring is 0, -1 gives 0, and then number of points try ring is 1, and that gives 1. Yeah, that's right. And that corresponds to this index and that index. And then here it's just the corner times number of points in the near fan. Although, again, this is different. Yeah, because, yeah, this is counting our overlaps again. So I have to do something like this. Try ring 0. How do I figure this out? Because I kind of need this value again, but I do need to know the number. Okay. I guess, well, there's always going to be 6 overlapping. So another way to do this would just be times 6 minus 6, but it's equivalent. So here, I do number of points in the far ring, minus 6, but of course it's different for the first ring because it only has 1. Okay, so I kind of know the answer. I'm just trying to figure out the best way to handle it. Yeah, so I guess this is fine. Okay, let's see. So at 0, when corner A is 0, which corresponds to here, or this line, we would get 0 as the offset. And then, because that's the number of points in the here, fan, -1. Oh wait, that's not right. Oh yeah, well it's times 0. Okay, so there's 1. It multiplies it by 1 every time, which is right. And then here it's by 2, so 0. And then when we move corner to 1, multiply it by 2, and that gives us 2, so it'd be 1, 2. So that's... I think this is right. But of course we just have the edge case when the tri-ring is 0, but... Okay, so let's try it again. I think that math is right. Still errors. Not the same again, so... Same size as a mesh array. Okay, let's just hack something so I can get through this and see what's going on with the triangles. So, mesh... Oh, wait. Train indexes... Safe set... We'll just set something to the num vertices -1, so it will definitely be the same size. Oh, I actually have to do a vector 3. And we know now that all the terrains are the same because there's no blending yet. Oh, this should actually be 0, I think. Actually, the terrains could be different because we have some blocks that are dirt and some that are stone. Okay, so let's see what's going on. Interesting. Go to the scene so I can see the wireframe. So they only created 1 triangle. That's why there were some misused. We should have a full hexagon at this point. Now, are they all on top of each other? Is it the points that are wrong or the fans that are wrong? Or are the triangles that are wrong, I should say, instead of fan. Okay, well, it's hard for me to imagine that the points are wrong. Let's, if I debug, we're going to get just a huge wall of text. That's not going to be much help. So we do it 1 for each corner to be consistent. I'll do that. I don't use this corner B. I didn't think I need to. Oh, there should be num points and far fan. That might make all the difference. Okay. Well, it made some kind of difference. Okay, how should I test this? I'm sure that I've made some mistake here in this math, probably. Let's walk through one corner at a time. So I'll do the first corner, and we'll see when it first starts to mess up. Okay, so right now this looks fine. Is that corner... It's actually going counterclockwise, isn't it? Because this is... it should go this direction. Alright, I bet that might have something to do with what's going on. But let's go ahead and make 2 and see if it continues in the counterclockwise direction. Okay, yeah, so now it starts to mess up. In a very strange way. Let's hide this because it seems like everything is congregating at the center point. So maybe we can see what's going on. Okay, so it's just going to 0, 0 because for some reason the position's not being set. Alright, so first of all, let's make it wind the correct way. Trying to figure out where that could come from. Because this is only different by 1 unless we loop back around, but... Okay, I think I need some way to test these points. Let's make the map a lot smaller. This is gonna be kind of a pain. I think it will complain to me that the monsters are out of bounds now. I guess I should fix that. So I'll go to a very hacky team building phase. And we'll just set this monster to 0, 1. Okay, so now we have a smaller map. There's still a lot of hexagons, but I don't know if I can make the map any smaller without the game complaining. Well, let's try. I think it's going to say that it's not a multiple of the chunk size. Let's put them inside each other, that's fine. And then I need to change the chunk size here in this mod to just 1. Okay, so that should work. Okay, so now I just have 1 hexagon. The reason I want to do that is because I want to print out every point as I create it to try and figure out what might be going wrong. So I know the center point is fine. So debug log. Let's do p plus points position. So I need to make sure that these points are correct before I go try to debug the triangles. I think this is the easiest way. Zero one zero one. That is weird. Okay, so yeah, this isn't what I expected. Oh, you know what? Okay, this is the issue. I don't take into consideration what corner that I start in, so I need that corner offset value. So it's number plus 1, and then so the corner offset is corner A. Then we multiply again. It's the same thing. If the point ring is I don't think I have to actually do that for this because if it's 0, then this will only run once anyway, so it will be okay. So it's just corner A times num points and fan minus 1. Okay, let's be a little bit cleaner about this string format. So ring corner point position corner A, P, and then there we go. Oh. Alright, so let's try this again. That would explain why we only had 1 triangle. And also why it went counterclockwise, because the last triangle was the one that was set. Alright, index is out of range. Let's look here. So ring 1, corner 0. Oh yeah, it's also making duplicates. So it doesn't have to create the last point because it will be taken care of by the next edge. Don't create last point will be created in next fan. Yeah, so this kind of stuff, even though it seems pretty simple, there's a lot of pitfalls you can come into, so you just gotta test. I think we might have gotten it to work. Yeah, so this should be the first fan. This is corner 0 and it goes clockwise around. Let's look at the positions. Okay, yeah, so just one. That looks correct to me. So I think we're safe to go ahead and create all corners now. I was thinking that I walked through that fan logic a bunch. I'd be surprised if it was still wrong. Alright, so let's hide the monsters. There we go. So now let's make it have one subdivision, which would have two fan ring, or yeah, 2 triangle rings and 3 point rings. And now we will have some missing triangles because we don't do the triangles that have 2 points on the near ring, but let's make sure this works. It does not work. So it looks like, let's see what's going on. Maybe the points are wrong. So ring 2 corner 0 is, that's fine. The points all seem fine, but I guess I should check that they're not overriding something else. Let's make this a bit smarter. I know that we're instantiating kind of a useless variable because it's not going to be used except in this debug log again, but I think the compiler might actually even take care of that problem for us, so it's not worth having bad code. Let's go into the scene and turn off the monsters. So yeah, so it's still weird. I just want to make sure that's not like overriding and the indexes. So the indexes should go up, but they don't. It goes back to 1. So the triangle logic still might be fine. Alright, so what happens there? We have the start index, and that should take care of it. Apparently it does not, though. Debug, log, start index. Let's look and see what that gives off. I have a feeling it's going to be 1 for all of these. Oh yeah, so ring 2, it's still giving 1. Why is that? Okay, so on ring 2, we're passing in 1 for this. So that's 0 times 1. And then we divide by 2. Okay, so obviously this code, or this... Okay, so 0 times 1 divided by 2. Well, yeah, that would give... that gives 0. But at 1, it should give... Should give 1, I would think. Let me see. So maybe I don't subtract. Yeah, so at 0, we want this to give 0. So it'd be 0 times 1 divided by 2 is 0. And so 0 times 6, blah, blah. So at 1, it would be 1 times 2, which is 2. Obviously, divided by 2 is 1. So 1 times 6 plus 1 is 7, which is right there. Okay, so I just think I got the indexing confused again. This should actually be at, I guess, point rings. So yeah, with 0 point rings. Okay. I think it might be my fault. I'm confusing 0 rings and 1 ring. So I think, yeah, this is ring 0, that's ring 1. Oh, yeah. Okay, that looks better. Although, we're missing 1 triangle. Probably has something to do with the modulo, I would guess, although I don't see any traces of it. Yeah, so I'm thinking it has to do with this right here, num points and far ring. So yeah, so this on triangle ring 2. Although it did work. It did work on the first triangle ring. Let's have another debug here. So debug log string format add triangle. I'll just print out the point indexes. So this is gonna be a bit verbose, but all right, let's see what that spits out. Okay, so we still have the same issue, but so it should be this very last one should. Okay, so 7 is here. Oh wait, no, 7's here. No. 0, yeah, 1, 2, 3, 4, 5, 6, 7. So it's going 7 and then 18 and then back to 7. Yeah, and all the other ones are at 6. Oh, because... Wait, what's going on here? Oh, I guess we need to also loop around at this point. Well, obviously, because we're having an issue there. So this would be the number of points in the near ring. I guess I'll add... that. Okay. Okay, there we go. I think everything is working. Don't see anything weird. Okay, so now let's do the other orientation here. Let's comment that out while I'm thinking about it. We can get rid of this. So I create triangles with 2 points on the near edge. Excuse me. And this happens. So we need to count. What's the number of points on the near fan minus 1? Oh yeah, fan minus 1. And it's something like this, except I need to make sure it winds correctly. So looking here, this is an example. So I guess we can start at the far. I guess it doesn't really matter. I could start here and then go like that. I think that's what I've done there. So the first one would be, yeah, this, except I don't need to loop at this point. Then the next one is far, and what is the... So if this is at 0, then we want the next one over, so we'd add 1. But we don't have to loop, actually, because there's always one more far point than near points. At least one more. And then here it's the near point, except we add 1, so I will need to do modulo. Okay, and I think that's all I have to do. Let me have a short debug here so we can test if there's any issues. Oh, it looks like it worked fine. Yeah, everything's covered up. Guess we can just look at the debug logs just to make sure. I accidentally added the point and not the index, but I don't know if we actually need it because I don't see any issues. Might as well run it again just to take a look to make sure that they're not like, I don't know, winding the wrong way, like it's going counterclockwise or something weird like that. Okay, so triangle 182. Yeah, so it is advancing clockwise. So I guess the last thing we'll do is increase the subdivisions and make sure that everything still works out okay. Yeah, it looks fine. All right. Now, before I move on to making the margin, I think while we still have things nice and simple, we might as well update to use normals. So first thing I'll do is here, or where do I do that? Yeah, right here. I'll use the make point. And this is the cells, or blueprint cells, cell index, center point. I also have to pass the block prototype. Okay, since I have to do that twice, let's get this cell object. All right, and the reason I'm going to do that is because that make new point will be what creates the normal map. So what I have to do, I guess I'll need to use the same kind of value, except I'll want to sample it at different, like at different lengths around. Okay, so I'll need to get like a, I don't know, a sample distance. Could just go one texel every direction, but I don't know if that'd be sensitive enough. It could be better if we let the mods decide, so let me see. Data, and this will be another value here in the board metrics, so and normal height, sample distance. Okay, so I think I'll switch this. I guess we can still have that function, but I want a float version. This will be get bump size. Could make this more efficient by calculating, I don't know. It'd be a little more efficient, I guess, if I passed in the actual height map instead of the prototype, but it's not a huge deal. All I do is just break that. I might even delete this function later, but it is a little useful. Get, so it'd be new vector 3 0, get bump size. Oh. Alright, so we'll just only update this function for now because we don't have to deal with lerping between two prototypes. We'll take that out because that's what we're going to be calculating. So I will need to get the distort amount and add that to the flat position before we send it to the bump height. So vector 3 position equals flat position plus get distort amount. Let's call this center actually. And then so float, I guess what do I call this? X min height is get bump size at flat position plus new vector 3, and this would be the data metrics. Oh, I have this, don't I? Maybe it's in the blueprint? Okay, I thought I had the database. Okay, so database metrics, normal height sample distance 0 0. And then we need to send the prototype as well. And so I'll calculate this for the X max and Y min, and I guess it should be Z actually because calculate it on the Z axis. Be positive, and then for Z axis I just move this over here. Okay. Now with that, kind of like coding has something similar, so just so I don't get hung up on the math. So yeah, so it gets the height at different areas in the height map. That's basically what we've just done. And then to find the normal, you can kind of take a cross product with a directly forward vector, and that will give you the normal. And an easy way to do that here is just take the difference between the U or the X values, and then the difference between the Z values for us. So we'll do that. Point dot normal is okay, so did it. Yeah, so it takes the first one, which is subtract minus the max. So yeah, I did this right. So X min height minus X max height 1. And then Z min height Z minus Z max height. Oh. It should just be new vector 3, and then I want to normalize this. So that is relatively simple. And then I guess we can still use this get bump height in case. Yeah, so I don't actually have to add or multiply that here. I can just do that here. Because the scaling factor would... well, no, it does matter actually. Yeah, because I'm not multiplying, I'm subtracting. So yeah, this function is pretty much useless, but it's still used here, and I don't feel like updating it right now. All right, so let's see if there are any errors. All right, so I don't really see much going on, but that might be just because the hexagon is kind of small. Let's look at the frame debugger, and that we can see the normals. Oops, window, frame debugger, enable. All right. Okay, so that's the normals. They look the same, actually. Oh wait, no, this is the normals, but still not much difference. I wonder if it's just because there's not enough. Well, no, the altitudes are different, so there should be a little variation. We could up the bump intensity. Where is that? That is in the block prototypes. So height, map, bump, length. Let's just, well, I'll leave what I had it at, but we'll give it something really big. Oh, an error. Okay, I can't put a comment in the middle like that. Fair enough. Okay, yeah, so now we can tell the altitude is definitely changing. So if I enable that, and let's turn off the monster prototypes. It's albedo, specular, normals. Okay, so normals are not changing, and these should definitely be different. That is... maybe I'm just setting it wrong. Could happen. I do set it right here. Let's debug it, print it out. Point dot normal, and just so we don't get spammed, I'll set the number of divisions back to 0. We still should see some differences. Oh, I bet it's actually because I never set the value in the board metrics. Let's just set it to, I don't know. It's in UV space. Oh no, it's in world space. Let's just set it to 0.05. That should be float as a default, and I'll need to remember to tie this into the terrain normals when we update the modding system. Should be terrain, normal, sample, length. Oh yeah, still not really. Well look, we got a little bit of curvature there, which could be because of the normals. Turn off monster models and change it to. No, they still look about the same. Okay, I guess, yeah, I should print out the normal. Did I already? I did. Let's look and see what that gave us. Okay, they are slightly different, but they mostly just point straight up. Okay, that tells me that... Okay, so it is working, but maybe this... I need to make this bigger to actually see anything. Let's do 2. I think the hexagon is like 1 meter across, so... Okay, you can definitely see the lighting. It's being affected now. Let's turn off monsters again. Okay, but there's not much different. I think this is slightly warmer, but... Yeah, but the normals are working. And by the way, you might think, well, this isn't normalized, but it's just because the default printing for vectors is not very good. It only goes to 1... Oh, what's the word for it? 1 point after the negative, and or 1 point after the decimal, so you don't see much information. Okay, but the normals are definitely being set. So let's... Okay, I'll leave that sampling there. Let's change the subdivisions to 2, and maybe even make the map a little bigger. And I'll change the chunk size back to 4. Back to 8. And maybe we can actually see the terrain at a larger scale. Oh no. Okay, well that took a long time to render. Something is... or a long time to load. But we do have... Yeah, we can see that the terrain, the normals are definitely interacting with the light. I wonder why that took so long to load that time. Was it... I guess it must be because of the terrain, but we've had terrain for a long time. I guess all these subdivisions really do add up. Okay, and again, let's switch to normals. Okay, I can't actually see anything. It has to be in the play screen, so... Yeah, well, there's still not a whole lot of variation, but that's, I guess that's to be expected. If I wanted to make it more extreme... I don't really know how I do that. I probably will want... I know there's a way that I can visualize normals, I think. Maybe not built in. That'd be a nice feature, though. But yeah, we can see a little variation in the green there, so it is being set up. And it'd be even more obvious if we had cliff faces, I think. But unfortunately, that's not implemented yet. But yeah, that's the basics of setting our own smooth normals. So now we need to update the margins, and hopefully it won't be quite as much of an ordeal as doing these. Now that I think the counting will be a little easier because we won't have it changing every ring outwards. Have it pretty visible right now, but I think I'll want to turn the specular pretty low for terrain. Maybe even, well, I guess I'll want to like have it editable. Even when the specular size is that low, it's still pretty strong. Probably because of the direction of the sun. Wonder what is going on with that. I don't see any of those effects with the monster models. And it's just a specular highlight. Okay, I think I need to get a normal visualizer so that like in the scene I'll have like little points visible where the normals are. I'll look into that in between streams, but I need to go get something to eat now. Alright. But yeah, I think we've made quite a bit of progress today, so I'm happy. But thanks everybody for coming out. I really appreciate it. And putting up with me trying to figure out that math. Tomorrow we'll hopefully finish up the margins and then we'll be done with the shaders for the weekend, and next week we'll start on another project. I guess it'll still be the same project, but another aspect of it. I think I'd like to do some more on the terrain because, like I said, I want to have dirt, stone, and grass complete, and then I'll move on to trying to make the game actually playable. So I'll need to do this camera. And then I'll need to do some rudimentary menus for the lobby and team building. Decoration models will probably need also for the grass, little flowers or something. And I think to clean up code, I'm mostly going to wait until the new version of Unity comes out. I have a lot of things I want to do here, but most of it, like right here, for multi-threading, will just work better with a new system. So there's no reason to work on it now before then. But yeah, that's it for me for today. Of course, I'll be live tomorrow at around noon Eastern. You can follow me here on Twitch or on Twitter if you would like to be notified when I go live. I also have a YouTube channel where I upload all past streams if you'd like to catch up. And a Discord channel where yeah, you can chat with me and other viewers throughout the day. We'd love to have you there. And I'll put links in chat and also on my video description. You can check there if you're interested. And yeah, that's it for me. Thanks again, everybody, for coming out, and I'll see you tomorrow. Bye-bye.